everyone, this is your Kalpana here. In this video, we're going to see a problem from partial differential equations. So let's get going. Problem: form partial differential equation z equal to x into f of y by x plus y into phi u of x by eliminating the arbitrary functions f and phi. So we are given a relation, say z equal to x into f of y by x plus y into phi of x, and we are asked to form a partial differential equation from it by eliminating f and phi, which are arbitrary functions. So let's see. Given z equal to x into f of y by x plus y into phi of x, right? Consider some equation number 1. Now let's partially differentiate it with respect to x. Just apply dou by dou x on both sides of the equation. Since we are partially differentiating with respect to x, so we'll treat y as constant here. This gives us dou z by dou x equal to, here you're having two functions, right? So we are going to apply u v whole prime formula, that is u prime v plus v prime u. So you'll get f of y by x into dou by dou x of x, partial derivative of x into this, plus x into partial derivative of f. Plus y is treated as constant into partial derivative of phi of x, that is phi dash of x. Okay, since we know that dou z by dou x can be replaced by the notation p, we'll just replace it by p. You'll get p equal to f of y by x into partial derivative of x with respect to x is 1 plus x into partial derivative of f of y by x is f dash of y by x into inner derivative dou by dou x of y by x plus y into phi dash of x. Okay, so here you are having dou by dou x of y by x, right? Here we are partially differentiating with respect to x. So we'll treat y as constant, right? So we'll write y by x as y into 1 by x, right? Now we'll take this constant out, so you'll get y into dou by dou x of 1 by x, that is derivative, partial derivative of 1 by x. We can say, we know that derivative of 1 by x is minus 1 by x square, since we are doing partial derivative. So partial derivative of 1 by x will be minus 1 by x square, right? So you'll get minus y by x square. Fine. This gives us p equal to 1 into f of y by x is y by x, that is f of y by x, plus x times f dash of y by x, partial derivative of y by x is minus y by x square. I am writing minus y by x square plus y into phi dash of x. Clear? This gives us p equal to f of y by x. X into minus y by x square is minus y by x, right? One x gets cancelled, otherwise you can say. Then you'll get plus into minus, minus y by x, that is minus f dash of y by x into y by x plus y into phi dash of x. Consider as equation number 2. Now let's partially differentiate 1 with respect to y. Partially differentiating 1 with respect to y. Just apply dou by dou y on both sides of 1. Here we are partially differentiating with respect to y, so we'll treat x as constant. This gives us dou z by dou y equal to constant into partial derivative of f of y by x is f dash of y by x into inner derivative dou by dou x of y by x plus here phi dash of x is treated as constant into partial derivative of y with respect to y. Okay, since we know that dou z by dou y equal to q, now let's replace it by the notation q. You'll get q equal to x into f dash of y by x, and it's y. Okay, I'm sorry, it's y because we are partially differentiating with respect to y, so inner derivative also will find with respect to y. Right, dou by dou y of y by x. Here we are partially differentiating with respect to y, right? We'll write y by x as y into 1 by x, and here 1 by x is treated as constant. We'll pull this out. You'll get 1 by x into dou by dou y of this y. Since partial derivative of y with respect to y is 1, you'll get 1 by x into 1, which is 1 by x. Okay, so partial derivative of y by x with respect to y is 1 by x. You'll get 1 by x here. This x gets cancelled because x into 1 by x is x by x, which is 1, plus phi of x into partial derivative of y with respect to y is 1. This gives us q equal to f dash of y by x plus phi of x. Right? Consider it as equation number 3. We got equations in P and Q. Now let's find the equation involving R. Okay, we know that R is nothing but dou square z by dou x square. We can write this as dou by dou x of dou z by dou x. We know that dou z by dou x can be replaced by the notation P, and this gives us dou P by dou x. So dou P by dou x is nothing but R. Dou by dou x of P is nothing but R. Dou by dou x of dou z by dou x is also nothing but R, and this is nothing but R, right? So in order to find equation involving R, we'll pick the equation involving P, that is equation 2. We'll pick equation 2 and we'll partially differentiate equation 2 with respect to x, so that we'll get equation involving R. So let's see that. Now let's partially differentiate equation 2 with respect to x. Partially differentiating 2 with respect to x. You can write P, or instead of P you can write dou z by dou x. Since P is nothing but dou z by dou x, both are same. Okay, instead of writing P you can write dou z by dou x, or instead of writing dou z by dou x you can write P. Now let's partially differentiate both sides of the equation with x. I'm just applying dou by dou x on both sides of the equation in order to eliminate, just remove errors. What I'm saying. In order to solve the problem without error, I'll just apply dou by dou x on both sides of the equation. Okay. Now this gives us dou square z by dou x square equal to, here we are partially differentiating with respect to x, so we'll read y as constant. We have to keep that in mind. Now partial derivative of f of y by x is f dash of y by x into inner derivative dou by dou x of y by x. Okay, minus partial derivative of f dash of y by x into y by x. We can use u by v whole prime formula here to find partial derivative of these two. Okay, minus of y by x into partial derivative of f dash of y by x is f double dash of y by x into inner derivative dou by dou x of y by x plus f dash of y by x into partial derivative of y by x. Okay, plus y is treated as constant, so write y into partial derivative of phi dash of x is phi double dash of x. Right. Since we know that dou square z by dou x square equal to r, just replace the LHS part by r, you'll get r equal to f dash of y by x into partial derivative of y by x. You can write y by x as y into 1 by x. Here y is treated as constant, so pull this out, you'll get y into dou by dou x of 1 by x, since partial derivative of 1 by x is minus 1 by x square. You'll get minus y by x square, since you have y into minus 1 by x square, which gives us minus y by x square, right? Just replace it by minus y by x square minus of y by x into f double dash of y by x into, again partial derivative of y by x with respect to x is minus y by x square plus f dash of y by x into partial derivative of y by x is minus y by x square. Okay, plus y into phi double dash of x. Now just simplify it. You'll get r equal to f dash of y by x into minus y by x square minus into minus plus y by x into y by x square is y by x cube into f double dash of y by x minus into plus minus into minus plus, we'll get plus f dash of y by x into y by x square plus y into phi double dash of x. Okay, now you can write this as, here itself you can write this as minus y by x square into f dash is minus f dash of y by x into y by x square, right? So here you have minus f dash of y by x into y by x square and plus f dash of y by x into y by x square, right? You can cancel this too and you'll get r equal to y by x cube into f double dash of y by x plus y into phi double dash of x, right? It's double dash, right? Consider as equation number 4. See, this equation involves r. And I did one more mistake here, that is y into y is y square, you'll get y square here, x into x square x cube, which is right, and here is y square, just it's not just y by x cube, it's y square by x cube. Okay, let's now find equation involving t. You know that t is equal to dou square z by dou y square. We can write this as dou by dou y of dou z by dou y. Since dou z by dou y can be replaced by the notation q, you'll get dou q by dou y. So in order to find equation involving t, we'll use equation involving q, that is equation number 3, and we'll partially differentiate it with respect to y, so that we'll get equation involving t. So let's partially differentiate equation 3 with respect to y. Partially differentiating three with respect to y. Instead of writing q, you can write dou z by dou y, since q is nothing but dou z by dou y, okay? Or you can just take q itself. Instead of taking q, I'm taking dou z by dou y for my convenience. You can take q if you wish to have q. This gives us dou square z by dou y square equal to, here we are partially differentiating with respect to y, so we'll read x as constant. Partial derivative of f dash of y by x is f double dash of y by x into inner derivative, that is dou by dou y of y by x plus partial derivative of phi of x is 0. Since we are partially differentiating with respect to y, okay, since dou square z by dou y square equal to t, just replace it by t, you'll get t equal to f double dash of y by x into partial derivative of y by x with respect to y. So you can write y by x as y into 1 by x, right? Here 1 by x is treated as constant, pull this out, you'll get 1 by x into dou by dou y of y. Derivative of y with respect to y is 1, you'll get 1 by x. So the value of this is 1 by x, write 1 by x. Yeah, this is your equation involving t. I'll get t equal to 1 by x into f double dash of y by x, or from this you can find the value of f double dash of y, f double dash of y by x, which gives us x into t or tx. Okay, consider it as equation number 5. We may use this later. Right. Now we'll find equation involving s. S is nothing but dou square z by dou x dou y, or we can write this in two ways: dou by dou x of dou z by dou y, or dou by dou y of dou z by dou x. Since dou z by dou y is nothing but q, so partial derivative of q with respect to x gives s, or partial derivative of z with respect to x is p, that is dou p by dou y gives s. Either you can pick equation involving q, or you can pick equation involving p. If you want to use equation involving q, we can pick equation 3 and partially differentiate it with respect to x to get equation involving s, and likewise you can pick equation 2 and partially differentiate it with respect to y so as to get equation involving s. You can use any of these two. I'm going to use dou q by dou x, okay? So partially differentiating equation 3 with respect to x, I'll just apply dou by dou x on both sides of 3. This gives us dou square z by dou x dou y equal to, here we are partially differentiating with respect to x, so we'll treat y as constant. Partial derivative of f dash of y by x is f double dash of y by x into inner derivative dou by dou x of y by x plus partial derivative of phi of x is phi dash of x. Since we know that dou square z by dou x dou y equal to s, we'll replace it by s. We'll get s equal to f double dash of y by x, and partial derivative of y by x is, we can write y by x as y into 1 by x. Here y is treated as constant, so pull this out, we'll get, okay, partial derivative of 1 by x is minus 1 by x square, so y into minus 1 by x square is minus y by x square. You'll get minus y by x square here, plus phi dash of x. Okay, so this equation, this can be considered as equation number 6, or you can write this as s equal to minus f double dash of y by x into y by x square plus phi dash of x. Consider as equation number 6. Since we have f double dash of y by x is tx, just replace it by tx and see what you are going to get. Since f double dash of y by x equal to tx, so this becomes s equal to minus tx into y by x square plus phi dash of x, where 1x gets cancelled, and you'll get s equal to minus ty plus phi dash of x. From this we can find the value for phi dash of x. Okay, phi dash of x equal to s plus ty. Okay, right. So s equal to minus f double dash of y by x into y by x square plus phi dash of x, which is equation number 6, and from this we'll get the value of phi dash of x, which is s plus ty. Okay, we'll use this later while finding PD. Right. Now observe all the equations we have now. See, here we have one x in the denominator, right? We should not forget it. We'll get by x. We'll get by x here. Right. Now observe all the equations. If you take R, you're having f dash and phi double dash. Do we have the values of f double dash? Yeah, you have value for f double dash, but you don't have the value for phi double dash, right? So let's see for P and Q. Here we have f dash into y by x plus y into phi dash, f dash plus phi. Okay, and also we have z, which is xf plus y phi. Here you have phi, here you're having f. And yeah, whenever we get stuck, we can check px, qi, s, x, y. It's not necessary to check everything. It depends upon the problem. Let's see. Okay, let's try px. If we find px, we'll have x into f of y by x minus x into f dash of y by x into y by x plus x into y into phi dash. Okay, now let's find qy. Just multiply y to this equation, you'll get qy equal to y into f dash of y by x plus y into phi of x. Okay, good. Here this x and x gets cancelled, then p equal to x into f of y by x minus y into f dash. See, here you have minus f dash of y by x into y, or y into f dash of y by x, and here you're having y into f dash of y by x. Okay, If you add px plus qy, you can cancel these two terms, right? And then you'll get x f of y by x plus y into phi of x, which can be replaced using z, because z equal to f x into f of y by x plus y into phi of x, and we'll get the extra term plus xy into phi dash of x. We can replace this phi dash of x using s plus t y by x. So let's add this 2. Now px plus qy gives x into f of y by x minus y into f dash of y by x plus xy into phi dash of x plus y into f dash of y by x plus y into phi of x, right? Where these two terms gets cancelled, and this gives us px plus qy equal to x into, I'll write these two terms first, plus the remaining term xy into phi dash of x. Okay, we can replace x into f of y by x using 1 is equal to z plus xy into phi dash of x can be replaced by s plus ty by x, right? This gives us s z plus xy into, take the LCM, you'll have sx plus ty by x, where 1x gets cancelled, and you'll get z equal to, z plus sxy plus ty into yty square. You got px plus qy equal to, right? Fine. Or we can write this as z plus sxy plus ty square equal to px plus qy. Now bring these two terms, just take this two RHS, you'll get z equal to px plus qy minus sxy minus ty square, which is a required partial differential equation. Okay. Or you can write this as xys in minus y squared t, whatever. Just required partial differential equation. This completes the problem. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.